Alright, are we ready? Okay, binomial theorem in your A maths itself, okay, I find that it is a important topic that we should actually not lose our marks in, okay, if you want to talk about being mark centric, okay. But the thing is that there are certain traps that people tend to fall in, especially when it comes to indices. Okay, because if your indices concepts are a bit weak, then you will actually oversee certain things, okay, overlook certain things, right? Then you end up making a lot of careless mistakes. Okay, but let's first try to understand certain notations that are commonly used in binomial first. Okay, so let's understand the notation n factorial. Okay, it is not n exclamation mark. Okay, this is called n factorial. Okay, it's not asking you to exclaim when you shout, when you say n. Okay, not asking you to say louder, right? So, what does n factorial actually represents? N factorial represents, okay, n times n minus 1 times n minus 2 times all the way till it ends at 1. So, for example, if I want to talk about 8 factorial, okay, so since we just passed Chinese New Year, 8 factorial, a very hot number, okay, it actually means 8 times 7 times 6 all the way to 3 times 2 times 1. This is what it means, okay. Important point to take note that 0 factorial is equals to 1. Okay? So the value of 0 factorial is 1. Later on, I'll tell you how to press calculator, but this is something to take note. Let me try to explain to you why. Okay? There are many reasons, many ways to go about explaining. I happened to be googling about it yesterday. Okay, I find that this is the easiest way. Okay? So, we understand, for example, I just give an example, okay, so that it's easier to understand. Let's say 3 factorial. 3 factorial, we know that it's 3 times 2 times 1, agree? Okay? Which is actually the same as writing 3 times 2 factorial, right? Because 2 factorial is 2 times 1. Agree? Okay? So, what we can say over here is that if there's an n factorial, I can have n times n minus 1 times n minus 2, and so on until 1. This part over here is also what we call n minus 1 factorial. So n factorial is equals to n times n minus 1 factorial. Agree? Okay. So what does this tell me then? Alright, about 1 factorial. Okay. 1 factorial will have to be following this formula: 1 times 1 minus 1 factorial, which is 1 times 0 factorial. Okay, and 1 factorial, we know that it must be 1, okay, because factorials end at 1, right? Okay, so if 1 is equals to 1 times 0 factorial, can 0 factorial be 0? Cannot, right? Because if 0 factorial is 0, 1 times 0 must be 0. Then, am I trying to say that 1 is equals to 0? Doesn't make sense, right? Okay, so in order for numbers to make sense in our factorial world, okay, our 0 factorial must actually be 1 in order for it to make sense that 1 is equals to 1 times 1. Okay, so this is one of those rare cases whereby, 0 times something, okay, is not going to be 0. Okay, so therefore, 0 factorial is 1, it is not equals to 0. Okay, so I hope that this helps you get an idea, okay. You don't need to go by explaining it, but I just want to make sure you're convinced that 0 factorial is equals to 1. Okay? Now, before we jump into calculator, let's do a little bit of algebraic skills in some sense. Okay? So, 11 factorial over 8 factorial. Okay? If I don't want to use my calculator, I need to know how does the cancellation work. Based on definition of factorials, 11 factorial means 11 times 10 times 9 times all the way to 1. Okay, and 8 factorial is 8 times 7 times all the way to 1. Okay, I intentionally write it like that so that we can see very clearly that 8 times 7 times whatever is all found over here. Since you're dividing, I can cancel it off. So 11 factorial over 8 factorial is 11 times 10 times 9. And that is 990. Okay, I think that one can do by mental calculation. 11 times 9 is 99, 99 times 10 is 990. Okay. So we need to be clear about how this cancellation works. Okay. Now what if I want to use calculator? Okay. Alright, so let's do a check. Is it really 990? Okay, so using your calculator, I want you to look for the button, okay, that has the exclamation mark with it. Okay, can we all do a check? Do we have that button? Okay, the one with the exclamation mark. So you can just press 11 factorial over 8 factorial. Okay, check whether you are able to get 990 or not. Okay. Okay, anybody has problems pressing your calculator? Can we get 990? Anna? Okay. Now, part B. Okay. What if I have n factorial over n plus 1 factorial? Okay. So go by definition again. N factorial is n times n minus 1. So please on minus 1 okay, by integer values. Then n plus 1 will start off at n plus 1 times n minus 1 times 1. So we see that we can cancel away all this. Okay, and therefore we are left with 1 over n plus 1. Okay. You may find that this seems a bit redundant and a bit like obvious, okay? But these are necessary skills, okay, before we jump into the serious stuff. Into the next notation that you need to be familiar with in binomial theorem, okay, which is this notation over here. Take note that inside it is not a fraction, okay, so be careful, don't draw a fraction line. It's just a pair of brackets, okay, and then n on top, r at the bottom. N and r will represent certain numbers which we will use later on, okay. But in order to read this, okay, we read this as n choose r, okay. Why do we call it n choose r? Later on, I think when you go to JC, when you learn combinatorics, okay, further study about probability and statistics, okay, then you understand the idea of n choose r method. Okay, so what does it actually represent? In your formula list, okay, in your exams, you will be provided the definition. So n choose r represents n factorial over r factorial times n minus r factorial. Okay. You don't have to go and memorize this formula. Right? Formula will be provided to you in the formula list. Okay. However, I want all of us to be familiar with how this could actually be simplified after we have covered this understanding already. Okay? So maybe I'll just write it out here. Okay. So n factorial over r factorial times n minus r factorial, right? What this means is that in the numerator, we are looking at n times n minus 1 times n minus 2, okay? Then maybe somewhere you have your n minus r. I don't know what is r, but r will definitely be less than n, okay? So maybe just a note here. R will be less than or equals to n. N cannot be lesser than 0. So from n, we start to count downwards, n minus 1, n minus 2, somewhere in the sequence you will have n minus r, then maybe n minus r minus 1, then after that we stop at n, stop at 1. Okay? Then for r factorial, okay, that will actually be your r times r minus 1 and so on, 21. Okay? Then after that, your n minus r factorial, proper brackets, n minus r factorial will be n minus r times n minus r minus 1 all the way to 1. Okay? I hope you are able to follow. Okay, so if I want to simplify this part, although it is already rather neat, okay, very simplified already, okay, just that later on when we go into binomial, sometimes you may need to know this skill. Okay, so if I want to simplify this algebraically, I know that this n minus r can be completely cancelled out, okay, because it exists in the numerator as well. Okay, so what is actually before this n minus r? It will actually be n minus r plus 1. Correct? So on the right, it will be minus 1 because it continuously minus 1. Okay, but before it will be greater than it by 1. Okay, because we're counting downwards in the descending order. Okay, so if I want to rewrite this, I can write it as n times n minus 1 times n minus 2 up to n minus r plus 1 over this thing about r factorial cannot be actually simplified. Okay. We won't be able to find a specific range inside it. Okay. So therefore, we can write it like that as well. Okay. For awareness, okay, Zurian, can you please wake up? Right? So for awareness as well, because if you read different books, different textbooks, they may not always use this notation. Sorry, my markers are not running out of ink. They may not always use this notation. Sometimes they may also use this notation. Okay. Sometimes they may also use this notation. Okay. So in case if you want to text me or email me whatsoever, okay, and you don't have mathematical function to write it to me like that, maybe you want to say 3 choose 2. Okay, you can tell me 3C2, I will be able to understand what you're trying to say. Okay, so that will be in texting lah, okay? But in our math working wise, please use proper notation. Okay. Alright, so now what do we do with this notation? Do I really have to always use the formula? Not really. Okay, most of the time, in fact, you'll be using your calculator to calculate. Okay, it's only on the rare occasions that you may need to do this algebraic breaking down. Okay, so let's learn how to press our calculator for 9 choose 4. What I want you to find in your calculator is a button, okay, that probably looks something like that. Okay. Right? Are you able to find it? May require some hunting. Okay. I'm using the Casio one, is above the divide sign. Okay? So what I want you to do to press in your calculator is to press it as 9. Okay, and you press the button, then 4. It should come out as 9C4 in your calculator. Okay? Right? So 9C4 should get you 126. Okay? We do a quick check. Then your calculator gives you that. Okay? So just to check whether is it consistent with the formula, it should. Okay, so if I use the formula, your 9 choose 4 represents 9 factorial over 4 factorial times 9 minus 4 factorial, which is 9 factorial over 4 factorial times 5 factorial. Okay, you could press this in your calculator, you should get 126 as well. Or if you really want to work it out, maybe somehow your calculator really break down, touch wood, okay? So it should give you 9 factorial can cancel out with the 5 factorial by removing the 5 factorial at the end. So we have 9 times 8 times 7 times 6, 4 times 3 times 2 times 1. Okay, you should get 126 as well. Okay. Questions? Want to show something, we have already touched upon proving when it comes to trigonometry last year. Okay, one method of showing is to do left hand side equals to right hand side. So in this case, we can start with the left hand side, 15 choose 3. Then we'll use our formula. Okay, because this suggests the use of formula, since there's factorial signs in it. Get it at this stage already. 15 choose 3 is your 15 factorial over 3 factorial times 15 minus 3 factorial, which means 12 factorial in denominator. Okay, then we open up the 15 factorial, which is 15 times 14 times 13 times 12 and so on. But I'm lazy, so I put it as 12 factorial, which you know already. Cancel it away, then we will get what we want to show as right hand side. Okay. Questions? Right? I think I'll leave it as such over here for today. Okay, go and digest this notation. Tomorrow we will continue. Okay, with furthering this notation, and then also on Pascal's triangle. Before we jump into the meat of binomial theorem. Okay. Alright, shall we end here? Please stand, let's read.